Here we go. Right, question 1. A car is starting from rest, okay? And what's happening is it starts from rest and decelerating uniformly. Car starting from rest and accelerating uniformly, travels a distance d in the first n seconds of motion and a distance k in the next n seconds. Prove that k equals 3d. Okay, so what we know is that it travels a d in the first set and it travels k in the next second. So we got to UVAS both systems, okay? So what we're going to do here is just UVAS both systems, and what we're going to get is the following. We're going to get UVAST, this is during the acceleration part, okay? S is equal to D, A is equal to car starting A, yep. V is equal to, we don't know. Rest equals 0, time, we have no idea about, okay? T is N. T is equal to N. Travels the distance d in the first n seconds of motion and distance k in the next n seconds. So this is like a question where you have a common start off point. The first distance is going to be d, the next distance is going to be k. So the next is going to be d plus k. So u equals 0. Remember, always use the same start off point. A is still going to be A. S is going to be d plus k. And d plus k, because the first distance plus the second distance. And t is equal to 2n. Okay. Now that that's done, all we got to do next is just use s equals ut plus a half at squared. Okay. So s equals to ut plus a half at squared. Okay. And what we're going to get is this. D equals 0 plus a half an squared. Okay. The next one's going to be d plus k. D plus k is equal to 0 plus a half a times 2n squared. Okay. So d plus k. Therefore, what's a d plus k equals 2an squared. This means that d is a half an squared, so take one away from the other, okay? So what you can find out now is that d plus k equals an squared. So what you're going to find out is that d is a half an squared plus k equals 2an squared. Bring the half an squared over the other side, and what you're going to get is k equals 3 over 2 an squared. You basically just have to find out that k is 3 times d. K equals 3 times d, okay? And that's the answer to that one. Okay. Now, for the next part, we're going to be on, we've proved the first one, so we're on question 4 now, yes? Question 4. View. Parents' backgrounds. Question 4. Question 4. A particle moving in a straight line with constant acceleration passes through 3 points, P, Q, and R, where Q is the midpoint of PR. The speeds at P and R are u and 7u respectively. Find the speed at Q in terms of u. Okay, so the moment I'm just going to read that twice because it does get fairly confusing sometimes. Particle moving in a straight line with constant acceleration. It doesn't say anything about it starting from rest, does it? No, it doesn't say anything about it starting from rest. So it's going u at the start. Passes through 3 points P, Q, and R. I'm going to put P. I'm going to put Q here. I'm going to put R further up the road. Okay. Now, where Q is the midpoint of PR. So we know that PQ is the same distance as QR. Okay. Now, the speeds at P is u, so it's going to use u at P and 7u at R. Okay. Find the speed at Q in terms of U. Show that the time taken to go from P to Q is twice the distance to go from Q to R. Alright, I'm going to UVAST both systems. I'm going to UVAST P to R. P to Q first. And then I'm going to UVAST P to R. Okay, so there's two systems. Okay. So, they're both U, aren't they? Yeah. What we know is that this is 7U at PR. We know that the acceleration is, we know nothing about the acceleration, all we know is A. We know that S is equal to, we'll call it, let's call this X, and therefore the other one is going to be 2X, okay? So X and 2X respectively, A. And what do we know about the times? We know nothing about the times at this point in time, okay? Okay, so what I'm going to first use here is we're going to go for what we're going to go for is if you look at the list, we haven't got T, but we have U, A, and S. So we'll go for phi squared equals U squared plus 2AS. Okay. The one we have more information about is PR, isn't it? For PR we have U, we have V, we have A and S. Okay, so we're just going to put all them in. So what we're going to get is 7U squared equals U squared plus 2A multiplied by 2X. Square that out, and you're going to get 49U squared equals U squared plus 4AX. This is going to come over to your side. It's going to become 48U squared equals 4AX. But minus U squared is 49 minus 1U squared is 48U squared. Okay. And we're going to divide it by 4. So we're going to get 12U squared equals AX. Okay. And A therefore is equal to 12U squared over X. Now that we know what acceleration is, let's concentrate on P to Q. So what we can do for P to Q is the same thing. We can say phi squared equals U squared plus 2AS. And I'm going to put a brackets PQ in. This means for P to Q. And what we can next do is we can say, okay, phi squared we don't know about. We're actually, our target for this full question, the first question is what phi is. The reason for this is, as you cross Q, phi is the velocity as you cross Q, because it's the final velocity of the segment P to Q. Okay? So what's going to happen here is phi squared is equal to U squared. And we're going to do 2AS, 2 brackets, 12U squared over X, multiply by S, which is bracket X. Okay? And what's going to happen here is the X's will cancel. Okay? And then we're going to get phi squared equals 2 multiplied by 12 is 24U squared, plus U squared gives you 25U squared. Phi therefore has to be equal to 5U. Okay? Everybody happy with that? Yeah. Okay. The next part is show that the time taken to go from P to Q is twice the time taken to go to Q to R. Okay? So let's do P to Q and Q to R. Okay? So what we're going to do is I'm just going to rub out the parts from the last part here. Okay? I'm just going to fill in our information. So we know that from the last part that this here, this is the information we got. This is 5U. Okay? And we now know that if we were to do the segment, QR, is everybody looking at QR? If we were to do the segment QR, we could say that U is now 7U. Phi is we don't know what. A is still, what's it, 12U squared over X, yeah? The distance of Q to R is X. So S equals X. And T is our target, okay? So we're looking to find out what t actually is, okay? So we actually know that the velocity 5u is actually the initial velocity at the point q, because v was the point at which you cross q, which makes it 5u, okay, and the final velocity is 7u, okay? So you can see that we have a lot of information about qr. We're just going to rewrite our information about pq as well, just to this side here, just keep it in the one area. U is u, v is 5u, a is 12u squared over x, s is still equal to x. Find out what t is. So I say the most easy formula to use here will just be simply phi equals u plus a t. Okay, so we're going to go for phi equals u plus a t, purely because we have enough information to use it. And what's going to happen here is the following, alright? So we're going to set it up for qr first. Okay, so qr, phi is 7u, u is 5u, a is 12u squared over x, and t we don't know. Okay, so what's going to happen is we're going to get 2u, okay, 7u minus 5u is 2u, and then we're going to have to divide it by 12u squared over x, and that's the same thing as turning it upside down, isn't it? I won't skip that part, alright, because I think it just takes a... Okay, the u's will cancel. Okay, so we're going to end up with 2x over 12u equals t. T is therefore equal to 1/6 x over u. So 1x divided by 6u. Okay, and that's the time taken for PQ. X over 6u. Repeat procedure. We did that for QR. Repeat procedure for PQ. Phi is equal to u. Oh, sorry. Phi is 5u. So 5u equals u plus at, which is going to be the exact same as last time. 12u squared over x times t. 5u minus u is going to give you 4u. 4u equals 12u squared over x times t. Bring the x up, cancel the u's, and what you're going to get is you're going to end up with 4x, bring the x up, bring the 12u squared down, and that equals t. Then you can just cross them off. U cancels with this u here, and then that's going to end up to be a third. Okay, so this t equals a third x over 3u, which is the exact same thing as 2x over 6u. So we've proved that t1 is twice as big as t2. So t1 equals 2t2. Okay. A particle travels with initial speed u, that's u vastus, u equals u, uniform acceleration a. Show that the distance traveled during the nth second is u plus an minus a half a. Now, if I was to ask you guys a question, and I was to ask you, I want to figure out from 2 to 3 seconds. Do you understand? 0 to 1 is the first second, 1 to 2 is the second second, and 2 to 3 is the third second, right? If I want to figure out how much distance is traveled in the third second, what I have to do is I have to say S3 minus S2, where S3 stands for the distance, the total distance traveled after 3 seconds, minus the total distance traveled after. So it just leaves the extra second you're traveling, yeah? Now, this is a bit more abstract than this, okay? What this is looking for us to do is it wants us to think of the nth second. So remember, the third second is 3 to 2, Therefore, the nth second is going to be n minus 1 to n. Do you got that? N minus 1 going up to n. Okay? Now, what we've got to do here is the following, okay? What we've got to do here is this, okay? Step 1 is to realize that we're going to set up two systems, okay? So two competing systems here. And the two systems are the following. The first system is the time equals, I'll put this in a different color, time equals n minus 1, or time equals n. I'm going to have to find out what s of n is and what s of n minus 1 is. Do you got it? And then I'm going to take them both away from each other. So what's going to happen here is this is s of n minus 1. That equals s of n minus 1. The time is n minus 1. And the final velocity I haven't got a clue about. This one here is t equals n, which means u is still equal to u. I'll use green for this one, sorry. U equals u. V equals, we don't know what. A is still A. S equals S of n. T equals n. Look at the list of what we have. U, A, S, and T. Our formula is going to be ut plus a half at squared. And my plan is to take away Sn minus S of n minus 1. That's my plan. Let's start off with the easy one. S of n. Get easy marks on the board. Ut is un plus a half a t squared being n squared. That's going to be un plus a half an squared. The next one is S of n is S of n minus 1. Okay? We know that the okay, so we know the time is n minus 1, okay? Okay, we know the time is n minus 1. So S of n minus 1, okay? And what we're going to say here is u into n minus 1 plus a half into a, and then we're going to go n minus 1 squared. Okay, so u n to the minus 1, a half a n minus 1 squared, okay? I'm just going to write out the answer for this. It's going to be, I'm going to put it in green, okay? un minus u plus a half an squared minus, when I square this out, it's going to be minus 2n, and then it's going to be 2n divided by 2, which is going to give you an. Yes, minus an. And minus an plus a half a. Now, what we're going to do, and we might save ourselves a bit of time by not writing them out twice. I'm going to take S of n minus S of n minus 1. So, to save myself a bit of time in the test, what I'm going to do is, I'm just going to come down here and put in minuses. Minus, plus, minus, plus, minus. un plus un cancels with minus un, yeah? So, 0. Minus u will stay where it is. Okay, so what's a un? Yeah. Okay, so that's going to be plus u now, so it's going to be u plus an squared cancels with minus an squared. Minus a plus an is behind u, and minus a half a, and that is what we're asked to prove. We're asked to prove that the distance travelled in the nth second is given by S of n minus S of n minus 1, and this is the answer for that. Okay? Now, the next question after this is, we're told the following information. We're told that the particle travels 17 minutes in the second of motion. and in the 47 meters in the 7th second of motion. How far will it go? So what we're going to do is the following. We're going to write down the following points here, okay? It's when n equals 2, which means when we're talking about the second, the distance travelled in the second, and you know the distance travelled in the second is represented by, this is the distance travelled in the blue box is the distance travelled in the nth second. Do you got it? So this blue box, when n equals 2, is equal to, it's going to be equal to 17. It's going to be equal to 17 because the distance travelled in the second is 17. Okay, so 17 equals, u stays the same. An is going to be 2a minus a half a. And what we're going to get here is u plus 1.5a equals 17. That is 1/2 of a simultaneous equation. The next part is going to be, we'll do this in purple. When n equals 7, which means in the 7th second, this blue box here, okay, I'll still use the blue box. The blue box turns to the number 47. And 47 is equal to this formula here, which is going to be u plus an. We know n is 7, so it's going to be 7a minus a half a. And what we're going to get here is u plus 6.5a equals 47. Now, what we have here is a simultaneous equation, a and b. For the purposes of saving time, I'm not going to solve that simultaneous equation. I assume you can handle it. Okay? Is that alright? So, what you can get is, when you do your simultaneous equation, what you're going to get is, you're going to get a equals 6 and u equals 8. And now, on the next section, what you're going to get is, we now know what a is 6 and u is 8. So if we reread the question, we're looking for how far will it go in the 10th second of motion. Do you got it? I'm actually going to answer part 2 first. I'm going to answer part 2 first, the nth section of motion, nth second of motion, okay? So to get the nth second of motion, all I'm going to do is, see this formula here? Yeah? This tells you how much distance is travelled in the nth section of motion. So all I'm going to do is replace in my numbers. A is 6, so it's going to be 8 plus 6 plus, what's it? 8 plus 6n. 8 plus 6n minus half of 6, which is 3. So the answer is going to be 5 plus 6n. This formula now equals 5 plus 6n. This represents how much distance is travelled in the nth second. So what we can do is we can go down, okay, and now we can say that distance travelled in n seconds is what's it? 5 plus 6n. Okay, 5 plus 6n. And what we're going to get with 5 plus 6n is the following. We're going to get, that's the distance travelled in the nth second. So we're just after answering part 2, haven't I? Yeah? To answer part 1, we want to know the distance travelled in the 10th second. So if it's in the 10th second, all you got to do is replace n with 10. So 5 plus 6 times 10. And what that will get you is 65 meters. Okay. Finally, The last part of this question says, during which 2 consecutive seconds will it cover 256 meters? Okay? So, what we know is it has to travel for 2 full seconds, doesn't it? We don't know which 2 full seconds it is. So let's start off with the general term, okay? The general term is this, lads. The general term is S of n is how much it travelled in 1 random second that we don't know about. And if we were to put S of n minus 1, yeah? That's how much time it travelled in the second before that, yeah? So all we have to do is use this formula. The distance it travelled in the nth second, which is the red one, is going to be 5 plus 6n. The green one is going to be the one that's travelled in S of n minus 1. And this one's going to be 5 plus 6 into n minus 1. Then what we can get here is add the 5's together. We get 10. 10 minus 6, isn't it? Yeah? 10 minus 6 is 4. 4 plus 12n. We know that 4 plus 12n must be equal to 256. It's okay, yeah. Now, what we're going to get is 12n equals 252. What's n divided by 252? Sorry? 21. I'll have 21. Now remember, for my example, I used n and n minus 1. So this is n, and n minus 1 is going to be 20. So hence I got the 20 and 21st second. If you set up as it did in the notes with S of n and S of n plus 1, you're still going to get 20 and 21. Your n is going to be 20, but you're still going to get 20 and 21. Okay, and that's the end of that lesson there, which is 27 minutes long.